So hello, ako nga pala si Jefford B. Cuevas. Ngayon ituturo ko sa inyo kung paano gamitin ang Guy-Lussac'S Law. So ito ang Guy-Lussac'S Law. Meron tayong equation na P1 over T2 equals P2 over T1. O di kaya P1 T2 equals P2 times T1. O yan po ang equation natin, at sa gagawin natin ngayon, ang gagamitin po natin na equation ay yung pangalawa, yung P1 times T2 equals P2 times T1. So, itong sample problem number 1 natin. The pressure of gas in a container is 1.25 atmosphere with a temperature of 403.15 Kelvin. If the temperature of the gas is increased to 450 K, what will be the final pressure of the gas when the volume remains the same? Dito, hinahanap natin yung pinaka-final pressure ng gas niya. Kaya ang hinahanap natin ngayon dito ay yung P2. Kasi meron tayong P1 na given, ang 1.25 atmosphere. Ang T1 naman natin ay 403.15 Kelvin. At yung P2 T2 ay 450 Kelvin. At unknown yung P2 natin. So makikita natin yan dito. Ang solution natin ay i-substitute natin lahat ng values sa formula natin, sa pangalawang formula o equation na pinakita ko kanina. So yan yung P1 T2 equals P2 T1. So ang P1 natin ay 1.25 times 400 T2, which is 450 Kelvin, equals P2. Kaya yung P2 lang linagay natin kasi wala pa kang unknown pa siya, wala pa siyang value. At yung katabi niya ito tayo sa 403.15 Kelvin. Ang gagawin po natin, 1.25 ito times natin sa 450K. At kapag na times po natin yon, i-divide po natin sa 403.15K. At yung pinakasagot niya, yung 1.40 atm, which is yung P2, yun na mismo yung pinakasagot ng P2 natin. So sa pangalawang problem po, para mas lalo natin maintindihan. So number 1, gas in a pressure cooker exerts a pressure of mmHg at 105 C. What will be the temperature of the gas if the pressure is reduced to 760 mmHg and the volume is constant? Kung meron tayong given, given, P1 natin ay 800 mmHg na tawag dito, natin siya, kinonvert natin siya sa units na atm. At kapag kino-convert po natin yan, kailangan natin i-times yan sa 0.0013 para makuha natin yung total niya sa ATM. At meron din tayong given T1 equals 105 Celsius. At i-convert din po natin yan into Kelvin. At para ma-convert yan, kailangan natin plus sa 273. So 273 plus 105 equals 378 Kelvin. At sa P2 natin, ganun din gagawin natin, i-convert din natin. At yung na-convert na 760 mmHg ay naging 1 atm. Ang T1 natin ay hinahanap, unknown. At yun ang hahanapin natin. Ngayon, gagawin natin ulit, sa substitute ulit tayo, substituting all the values to the formula we have. So, meron nga tayong formula kanina, which is yung P1 T2 equals P2 T1. So, ito na nga, P1 natin ay 1.05 atm at missing yung T2 natin equals 1 atm, which is yung P2 natin, at yung T1 natin ay ang T1 natin ay 378K. So T2 pala yung hinahanap natin, hindi T1. So T2 equals 1 ATM, 378K over 1.05 ATM. So, paano ba nangyayari dito? So, dito yung katabi ni T2, yung P1 natin, ilalagay natin sa kabila. Kumbaga, divide naman siya para makuha natin yung pinaka-result niya. Para walang katabi si Tito yan. Tapos, i-times mo yung 1 ATM times 378 Kelvin. At ang sagot natin ay 378 po. So, pag dinivide natin yon sa 1.05 ATM, tatanggalin natin, i-cancel ATM, so magiging Kelvin. Kelvin na lang matitira. At yung pinaka-answer natin ay 360 Kelvin. So, hanggang dun lang. Salamat.
So hello everyone, and I'm Queen Eliza de Seda from Grade 10 LINNE. For today's video, I'm gonna show you the facts and some informations about French chemist Joseph Louis Gay-Lussac. So guys, I want you to know that French chemist Joseph Louis Gay-Lussac is the one who invented the Guy-Lussac'S Law. Joseph Louis Gay-Lussac was born December 6, 1778 at Saint Leonard de Noblat at France, and died May 9, 1850 at Paris. French chemist and physicist who pioneered investigations into the behavior of gases, established new techniques for analysis, and made notable advances in applied chemistry. Gay-Lussac was the eldest son of a provincial lawyer and royal official who lost his position with the French Revolution of 1789. His father sent him to a boarding school in Paris to prepare him to study law. Early in his schooling, Gay-Lussac acquired an interest in science, and his mathematical ability enabled him to pass the entrance examination for the newly founded École Polytechnique, where students' expenses were paid by the state. Although the school was designed primarily to train engineers, chemistry formed an important part of the curriculum. Gay-Lussac proved to be an exemplary student during his studies there from 1797 to 1800s. Upon graduation, he entered the prestigious École Nationale des Ponts et Chaussées, or School of Bridges and Highways. He withdrew from this school in 1801 to become chemist Claude Louis Berthollet's research assistant. Berthollet, who had recently set up a laboratory in his country house at Arriesgado, just outside of Paris, became the famous of a small but very influential private scientific society. The society's first volume of memoirs, published in 1807, included contributions from Gay-Lussac. As a young man, Gay-Lussac participated in dangerous exploits for scientific purposes. In 1804, he ascended in a hydrogen balloon with Jean-Baptiste Biot in order to investigate the Earth's magnetic field at high altitudes and to study the composition of the atmosphere. They reached an altitude of 4,000 meters, about 13,000 feet. In the following solo flight, Gay-Lussac reached 7,016 meters, more than 23,000 feet, thereby setting a record for the highest balloon flight that remained unbroken for a half-century. In 1805 to 1806, amid the Napoleonic Wars, Gay-Lussac embarked upon a European tour with another Arriesgado colleague, the Prussian explorer Alexander von Humboldt. Gay-Lussac's research, together with the patronage of Berthollet and the Arriesgado group, helped him to gain membership in the prestigious first class of the National Institute, later the Academy of Sciences, at an early stage in his career in 1806. Although no vacancy in the chemistry section existed, his credentials in physics were sufficiently strong to enable him to enter that section. In 1807, he published an important study of the heating and cooling produced by the compression and expansion of gases. This was later to have significance for the law of conservation of energy. 3 years previously, Gay-Lussac had been appointed to the junior post of repetiteur at the École Polytechnique, where in 1810 he received a professorship in chemistry that included a substantial salary. He was also granted a professorship in physics at the Faculty of Science in Paris upon its founding in 1808. In that same year, he married Genevieve Rojot. The couple eventually had 5 children.
Baby, baby, you're my sun and moon.
Hello everyone, today I'll be showing you our experiment on Guy-Lussac'S Law. So, in our experiment, we have a jar, a plate, a candle, lighter, and water. First, we're gonna light up our candle. Then we'll put it on the plate. Then put it in the middle of the plate. So after you put it in the middle of the plate, pour water. Then after you put the water, put the jar over the candle. So there. So look here. The water is slowly going inside the jar. And also you can also see that the flame in the candle is slowly going out. So that is the experiment for Guy-Lussac'S Law, where the flame in the candle has been burnt out and all the water in the plate, here you can see, are inside the jar. So how is Guy-Lussac'S Law shown in this experiment? Well, I'll explain it to you. When the jar was placed over the candle, the fire in the candle begins to rise up into the air. So, the fire went up into the air. So, when the air inside the jar is heated, the gas particle expands and thus putting the pressure on the water that has a heated pressure that is equal on the higher air pressure. But how is that possible? Well, stated in the Guy-Lussac'S Law, in where pressure increases, the temperature increases as well. And that is where the air pressure decreases, making the water rise up. So again, I'll give you a short summary of my explanation. The flame warms up, the air expands, then momentarily stops the air's depletion. Then after that, the water level rises. And that's all for the Guy-Lussac'S Law.
DJ Komang Remake. Hello, my name is Kennedy Arriesgado, and I'm going to show you how to solve the Guy-Lussac'S Law. So the formula of Guy-Lussac'S Law when it comes to problem solving is P1 times T2 is equals to P2 times T1. So let's have an example. So let's say our P1 is at 2.00 atm and our initial pressure or T1 is at 20 degrees Celsius, and our final pressure is missing, and then our final temperature is at 110 degrees Celsius. So before you have to solve, you must convert to both initial and final temperature into Kelvin. Okay. So let's proceed to the conversion factor. So we have to convert from degrees Celsius to Kelvin. So here's the formula. And since we know the formula, let's convert. So the first one is 20 degrees Celsius, and we add that to 273 is equals to 293 Kelvin. And the next one is the final temperature, which is at 110 degrees Celsius plus 273 is equals to 383 Kelvin. Alright, let's write that down here. Okay, so since we finished converting both initial temperature and final temperature, let's start solving. So we're going to use this formula, and we have to substitute each of them. So our P1 is 2.00 atm, and then our final temperature is 383 K. Is equals to, and then the final pressure is missing, so we just have to copy that, and then our initial temperature is at 293 Kelvin. Alright, so we already substituted this one, so we're going to start multiplying this and this one. So 2.00 atm times 383K is equals to 766, and we don't have to forget both of these units, so atm K. So the next step we're going to do is copy this, and then use this one as our divisor. Okay, so this one will be our final step. So since they're both divisible, so they're cancelled, and then we have to remove these units because they're similar, so we're only left with atm. So 766 divided by 293 is equals to 2.61, and then we can forget the remaining unit, which is atm. So this will be our final pressure. So what have we noticed? We've noticed that the final pressure has been increased and it is now greater than the initial pressure. So that's all for today. And again, my name is Kennedy Arriesgado. I'll see you next time.
Good evening everyone, my name is Claver, and today we'll be solving a gas law, specifically Guy-Lussac'S Law about gases. So let's say we have a tire that has 1.88 atmosphere at 25 Celsius. So what will be the atmosphere if the temperature rises from 25 to 37 Celsius? So by reading the problem, we get the following: 1.88 atmosphere, 25 Celsius, and 37 Celsius. We convert the Celsius into Kelvin. So here's the solution. Pressure 1 over temperature 1 is equal to pressure 2 over temperature 2. Then we substitute our following. So 1.88 times 310 then divided by 208, then we get 196 atmosphere. As simple as that, that would be the end of our video. Thanks for watching.
Guy-Lussac'S Law, created by Joseph Louis Guy-Lucas. It is a variant of the ideal gas law, where the volume of the gas is held constant. Louis Gay-Lussac was a French chemist and physicist, known for his discovery that water is made of 2 hydrogen and 1 oxygen atom, and for creating 2 gas laws related to gases that became known as Guy-Lussac'S Law. Guy-Lussac'S Law is a law that states volumes of gases undergoing a reaction at constant pressure and temperature are in a simple ratio to each other and to that of the product. Here is a candle experiment using Guy-Lussac'S Law. The breaker is placed over the candle and the flames heat up the air. When the air is heated, the gas particles expand and move faster, putting pressure on the water, making it rise. Here's an example of Guy-Lussac'S Law in the formula. Here's a sample problem. (400 kPa) missing, morning temperature, 420 kPa, 39 Celsius. Using the pressure law, which states 400 over T equal 420 over 312. Meaning, T1 equals 400 times 312 divided by 420. The answer is 207 Kelvin, which we convert to Celsius, making the answer 24 degrees Celsius. That is all.